Okay, how are you everybody who is attending this session? I'm very happy and I'm very glad to have you today. My name is Olenjolain, TAYAI single. I'm very happy to welcome you into this fantastic moment, and we are in Department of Basic Mathematics, and these contents are for the Form 2, and we are in the first chapter, Chapter 1, which is called Exponential and the Radicals. So I think that you have been going through Session 1, Session 2, Session 00, Session 3, and today we are in Session 4 when we are going to teach about the laws of exponent. This is a very important part of the entire chapter of exponents and the radicals. Why? Because in most NECT exams, for example, the Form 2 NECT exam or the Form 3 TAYAI exams, in some of the regional which have the Form 3 exams, or in the NECTA, or it means Certificate Secondary Education Examinations, we call the NECT exam for the Form 4. This is the most part where you will find so many questions testing about your understanding. So I would like to ask you to be seriously and concentrating and make sure that you do the quizzes that I'm going to give you, and also I insist you to do the homework that I'm going to leave for you. And you are not limited to go extraordinary, it means to go beyond of what I'm going to teach you. You're not limited also to go through the contents that will be taught by your classroom teacher with this content. So you have to combine what you've been taught in your classroom and what am I going to teach you. But it's a matter for you to concentrate on the contents which are well sequential. But before I start the sessions, I would like just to ask you that when we'll be learning this topic, we need some reference book. First of all, it's a syllabus called the Basic Mathematics Syllabus for Ordinary Secondary Education. You should have this book, a copy of this book. You can order it online, and then I can ship in any regions across the country of Tanzania. So this is a very important book because you need to use it when you are learning Basic Mathematics Form 1, Basic Mathematics Form 2, Form 3, and Form 4. And when you graduate, also you need for your young brothers. But another reference book is the book called the Secondary Basic Mathematics Book 2. This is the book that you are going to use on learning all of these contents of Basic Mathematics Form 2. But another book is the small book called the 4-Figure, or called Maximilian's 4-Figure Mathematical Tables and Formulas. We need to use this book on the next sessions or the next subtopic called the radicals, right? So all of this stuff, you can get them as soon as possible when you are in need of them. So let us go to today's session. In case you have any questions, you are allowed to ask me along the way. Okay, so let me do the quick review. Quick review means I am trying to link today's session and the previous session. So quick review of session 3. So in session 3, basically we did some questions, but what we are trying to teach you, about key points. The first key point is something we call power. So power, this is base, and then we raise with exponent. But the next thing that we have been teaching you on how you can identify the base when you be given a certain exponent. But another thing we have taught you to determine how you can find the exponent, right? And then the next thing, we taught you how you can find the value of a particular exponentiation. For example, if you have 2 times 2 times 2 times 2, the value is equal to 16. Again, another concept which we taught you how you can write the power, means how you can write the power in expanded form. How you can write the power in expanded form. But also we taught you how you can write the expressions in expanded form into exponent or power form. That's what we've taught you. But again, we've taught you how you can think about how you can write maybe a particular value. How you can write a particular value in base 1, in one base, and also you can write the same particular value in base 2. That's what we've been teaching you when we've solved the question, we've solved the exercise 121, exercise 121 or exercise 2. Exercise 121 from question 1 through question 6. So today we are going to deal with laws of exponents. Say with me, laws of exponents.
Laws of exponents.
Because if you say, actually, that you write in your mind, and then you can pronounce what are we going to learn. So let us go to today's session. Exponents are divided. Exponents are divided. Okay, exponents are divided into three groups. That are. So we can divide exponent into three groups that are. The first group we call it based on, or exponent based on the. So let me write. So we have three main categories of exponents. The first category is exponents. Exponents based on positive intervals. Exponents based on the positive intervals. Okay, based on the positive intervals. So exponents based on positive intervals. So when you say that based on exponents based on the positive intervals, exponents, mean that these are the exponents where that the exponential value is positive interval. Also, you have exponents with zero exponents. With zero exponents. When you say zero exponents, for example, we have 6 power 0, or we have 7. So example, we have, let's say, y power 0, or we have, let's say, 72 power 0. So this is what it means. When you say about exponents based on the positive intervals, for example, 6 power 2, 4 power 3, 5 power 6. So these are the positive intervals. Positive what? Intervals. This is positive integral, positive integral, positive integral. When you say exponents with zero exponents, because these are the exponents. This is the case. Then the third category of exponents is exponents with negative interval. Exponents with negative intervals. We haven't discussed this part. Exponents with negative intervals. Negative intervals is negative integral exponents. So what do we mean? Example of this category, we have 6 power negative 2. Right? So you see the exponent here is negative. It's no longer positive, right? And then also you can have, let's say, 4 power negative 3. So you see the base is 6, exponent is negative 2, right? Yes. Here the base is 4, exponent is what? Negative 3. So that's the meaning of exponent with negative integral exponents, right? Yes. Again, we can have, let's say, y power negative 4. Also, you can have maybe z power negative 11. Also, you can have, let's say, 21 power negative 7, etc., etc. So when we'll be learning about laws of exponents, we'll be categorizing. We have laws of exponents regarding on this, laws of exponents regarding on this second category, laws of exponents regarding on this third categories. So we have never discussed about this exponent or exponential or exponents with negative integral exponents, but we'll discuss them later, right? Yes. Okay, cool. So we can categorize the laws of exponents in this category. So we can start with multiplications and the divisions of positive integrals exponents. So let us start with first category. Exponents with positive integrals. So that is the first category. So we are dealing with what? Multiplications and what? Division. Multiplication and what? Division. Multiplication and division of positive intervals. Multiplication and division of positive interval. Positive what? Positive interval exponents. So we are dealing with the first category. We are dealing simply with exponents with what? Positive interval exponents. Positive interval exponents. Manake unaanza kuangalia exponent ambazo zina exponent ambazo ni chanya. Manake tendo lake ni chanya, so has on the first type. Okay? So with this one, we are dealing with multiplications and what? Division. Right? How we can multiply exponents with positive intervals. Right? And then how we can divide exponents with a positive what? Interval. That's the case. So let us start with Roman 1, multiplication law. So today in this session, I'll teach about multiplication. What? Say multiplication law.
Multiplication law.
Multiplication law. Multiplication law of exponents. Multiplication law of what? Exponents. So, multiplication law of exponents, we say that given the two exponents of what? Of a power n and b power and what? A power n. Okay, given two exponents of a power m and a power n. Then, if you are finding the product, or if you take a power m and you multiply with a power n, under the condition that they have the same base, this one, the law states that is equal to a power m plus n. So law of exponent, the simple way of law of exponent, we say that so the multiplication law of exponents state that, so say that if we multiply, if the two exponents of the same base, are multiplied together, then the product, then their product is equal to the base with summation of exponents. Summation of exponents. General. What does it mean? This multiplication law states that like this. If we have exponent a power m, we multiply it with another exponent, which is a power n. The exponents are not the same, right? But the base is the same. Because we say that if the two exponents of the same base, the base here is a, and the base here is what? A, right? Are multiplied. This is multiplication, right? Yes. Multiplied together. Then the here product is equal to, so this one is equal to, right? What? The base, what the base here is a, right? The base is what? Summation of what? Of exponents. What the exponents of a here is m. What the exponents of a here is m, right? Yes. What the summation is m plus what? N. So this is law of multiplication of exponent. You have to remember it for the rest of your life. Even if the base is b power n multiplied by b power n, the response still that b is m plus n. So don't worry about the base. Remember that the base should be the same. But if you have different base, for example, here it is a power n multiplied by b power n, you cannot apply this law because the base is not the same, right? So it depends. So for that case, we cannot do the simple base operations of summing the exponent. If the base is not the same, we cannot apply this law. So this law is applicable if the base of the two exponents is the same, right? In case it's not the same, we'll teach you later what you should do, right?
Yes.
So that is, we call it what? Multiplication law of 40 exponent. Say multiplication law of 40 of exponent.
Multiplication law of exponents.
With the same base.
With the same base.
Yeah. The condition is with the same what? The same base. Okay. So, example 11. Have to refer secondary basic mathematics book 2, the one that I mentioned at the beginning. Okay. So the question will say, write each of the following. This is an example. Write each of the following. Write each of the following expressions with a single exponent. With a single exponent. With a single exponent. A. You have 7 power 6 times 7 power 8. B. You have 6 power 4 times 6 power 3 times 6 power 4. C. You have 5 over 9 power 3 times what? 5 over 9 power 4. And you have D. D, you have 0.45 power 2 times 0.45 power 4 times 0.45 power 12. So you can realize that example 12 tests your understanding on how you can employ the law of exponent, of multiplications of exponent, to find or to answer the question. So let me repeat again. Example 11 asks you to write each of the following expressions with a single exponent. So it is a single exponent? No, this is two exponent, right? Two exponent, first exponent, second exponent, right? And then here we have what? 3 exponent. 1, 2, 3. Here you have 2 exponent, 1, 2. Here is 3 exponent, 1, 2, 3. So the question asks you to write each of the following expressions in a single exponent. What it means of the single exponent? A single exponent, it's a number with a single base and single exponent. And there is no any multiplication sign in between, right?
Yes.
So, solution. So, we say that in order to solve all of these questions, Means question or example 11 from Roman A to Roman B. We have to say the first step. We are going to follow a number of steps. The first step we call multiplication law. Multiplication law, right? Of what? Of exponents. How does it state? Suppose that two exponents have the same base. A power n multiplied by what? A power n. This is equal to what? A power n plus what?
n
Plus n. So this is the single exponent, while these are the two exponents. Right?
Yeah.
Similarly, we can also extend this law into a power m times a power n times a power, let's say r, times a power q. This also is equal to how many exponents do you have there? 4 exponents, right?
Yes.
First exponent, second exponent, third exponent, fourth exponent, right?
Yes.
So with this one, the same law will be applicable because all of the 4 exponents have the same what? Base. So we add what exponent? So a power m plus n plus r plus what? Q. So you see that this is a single exponent, but it's resulted from what? 4 exponents of the same base, right? So you may combine either 2 exponent into single exponent, or 3 exponent into the single exponent, or 4 exponent into the single exponent, or 5 exponent into the single exponent. So don't worry about the number of exponents. The same law will be applicable under the condition that they have the same base. If they don't have the same base, then this law will not be efficient for that case. All right?
Yes.
So Roman A, what are we given? We'll be given 7 power 6 times what?
And 7 power 8.
How many exponents are there?
2.
2. Okay. What they are base? 7.
7.
They have the same base? Yes. And then the exponent is what? 6 and 8.
Yes.
So the exponents may either be the same or may be different, but the base should be the same. Right?
Yes.
Let me repeat. Exponent may either. So it means, for example, I can have a power m times a power m. It can be the same exponent, right? But the base should also be the same. It can be either have the same exponent or different exponent, but the base should be the same. You get my point? Okay. So even this one, a power m. So you say that the answer is a power m plus m. So the answer is a power 2m. Right?
Yes.
Right?
Yes.
So don't worry in case that they have, for example, I can have 7 power 60 times 7 power 6. So don't worry because the exponent has the same value. You have to take, the answer will be 7 power 60 plus 6.
If the exponents are not different, then
Are not the same. That's what I'm saying. For example, you have 7 power 6 times 7 power 60. The answer is equal to 7 power 60 plus 60. Don't worry about that. So the main point or the main thing you have to consider, they have the same base. That's all. Don't worry about the exponent if they are the same or they are different or whatever. Right?
yes.
Yeah. So with this one, if you apply, what law are we going to apply? It is a power m times what? A power n is equal to a power m plus what? N, right?
Yes.
So in this one, 7 power 60 times 7 power 8, it is equal to 7 power 60 plus 8, right? 6 plus 8 is equal to what? I have my physical students here who are really sleeping. 6 plus 8 is equal to what?
48.
Hey, they are doing the manual computation. It is 14. Okay? So the response, therefore, to write 7 power 60 times 7 power 8 in the single exponent, this is 7 power 14 as the response. You are done. You go for Roman B. Roman B, we have what? We have what? So you can try. So Roman B, this is quiz. You can try now because after the same base, you just add the exponent. Right?
Yes.
Then let us go Roman C because I want to challenge you. Roman C, we have what? We'll be given what? 5 over 9 power what? Power 3 times what? 5 over 9 power what? Power 4. Don't worry. The key point, I told you that if you have a power m times a power m, the answer is equal to what? A power m plus what? Plus m. Right? So what the base of this exponent? 5 over 9. What the base of the second exponent? 5 over 9. What are the exponent? 3, and here it is 4. Right? According to law, they have the same base. So we have 5 over 9. Then we have what? 3 plus what? 4. Right? 3 plus 4 is equal to what? 7. So to write this exponent in the single, we have 5 over 9 power 3 times what? 5 over 9 power 4. The answer is equal to 5 over 9 power 7. And the response. I believe that you're enjoying the beauty of basic mathematics for the Form 2. And I believe that you're enjoying the beauty of exponent. Because exponent is beautiful. Real beautiful. Don't know about your side. On my side, it's real beautiful. So Roman D, we have now a decimal, a base of decimal, right? We have what? 0.45 power what? Power 2 multiplied by what? 0.45 power what? Power 4 multiplied by what? 0.45 power what? Power 12. So what should you recall? How many exponents do you have? 3 exponents, right?
Yes.
So simply you can say that we have to recall a power m times a power n, because the exponents are not the same. Then times a power r. This is equal to what? A power m plus r plus n plus r. Right?
Yes.
What the base of these 3 exponents? Is 0.45, right? What are the exponents? 2, 4, and what? And 12. So do they have the same base? Yes. So because they have the same base, we can add what? Exponent. So therefore, we say that 0.45 power 2 multiplied by what? 0.457 power what? Power 4 multiplied by what? 0.45 power 12. This is equal to 0.45 power 2 plus 4 plus 12. Right?
Yes.
So therefore we say 0.45
16.
power 2 times 0.45 power 4 times 0.45 power 12. This is equal to 0.45 power 18. So that the response power 18. Then you are done. Nothing is difficult in mathematics. It depends the way that you translate. Okay, so that's the first multiplication law. So let me teach you second multiplication law. Second multiplication law of exponent. Second multiplication law of exponent. And this second multiplication law of exponent actually deals with what if we multiply two exponent functions and we differentiate the exponent by using the bracket. So the second law, so listen, given a power m and the a power n, right? Then when you have a power m open bracket and close bracket, times n. Stop writing. The second multiplication law is we have a first exponent, right, in power form. Then we multiply it with n another exponents outside of the bracket, right? So this is, for example, it is 4 power 3, but we open bracket and close bracket power 4, right? How are we going to deal with this? So this one, the law states that if you have a power m, then outside of the bracket we have another exponent which is n. With this one, we say that this is equal to a power m multiplied by a power n. You have to understand carefully, right?
Yes.
This is not true. The law states that we have a power m times n. What does it mean? So this one, we say that is equal to a power m times n. So if we find any situation that we have exponent raised with n, then we multiply the exponents. I think that is not clear. Listen carefully. I say that if you've been given a problem, remember a is any base, can be any number, and decimal number, any fraction, or any whole number, as we have seen in the previous example, right? Then this one is raised with a certain exponent, it's a certain value of exponent, which is m. But again, the whole response, we raise it with another exponent, which is n, right? But this n, it's outside of the bracket. In order to do the computations, in order to find the value, or in order to express this exponential form in a simplified form, then we say that we write the base the way it is, but we multiply these exponents. So in case we find that the two exponents, but they have been separated by the bracket sign, right? What does it mean? It means that these exponents are multiplied. These exponents are what? Are multiplied. Right?
Yes.
So, don't worry, I will give you an example. You'll understand in example. Let me clarify, because I know that in many students it's not clear, the concepts is not clear. What does that second law mean? For example, if you'll be given 3 power 4, right? We know that this is power form of exponent. This is base, this is exponent, right?
Yes.
But again, we have another exponent outside of the bracket, which is 2, right?
Yes.
Usual, we used to say that this is 3 power 4 multiplied by 3 power 4. What I mean? You agree?
Yes.
Writing this way, 3 power 4 power 2. This means 3 power 4 times 3 power 4. All right?
Yes.
How many 3 power 4? 2. 1, 2. That's why we have these 2. If you write, let's say 4 power 6, then here we have 3. So this is equivalent if I write 4 power 6 times 4 power 6 times 4 power 6. That's the meaning. All right?
Yes.
All right? That's the meanings of this 3. It means this 4 power 6 has to multiply itself for 3 times. Right? This 4 power 4, this 3 power 4 has to multiply itself twice. Okay? So this one in mathematics, instead of writing the expanded form like this one, we just write that this is equal to what? Because 3 power 4, for example, if you're applying the multiplication law, 3, the same base, right? What you have to do, you add the exponent, right? So it means that it will be 3 power 8. Power 8. Are you together?
Yes.
Normally. So it means that this is 3 power 8. If you're using what? The multiplication law, right? But according to the new law, which I told you right now, we say that this one, we take that 3 power 4 times 2. 3 power 4 times 2. What does it mean? The new law, I told you, is a power m raised power n, right? So this one, I told you that this is equal to a power m times what? M. If I take this one, 3 power 4, right? And then 2, it means A is equal to 3, right?
Yes.
M is equal to what?
4.
4. N is equal to what?
2.
2, right?
Yes.
So if you write the expanded form, you'll get this one. If you're applying the multiplication law, you'll get 3 power t power n, right?
Yes.
With this new law, there's no need for us to write in expanded form like this. This is equal to, if you say 3 power 4 times 2. Why? Because we apply this law. Right?
Yes.
Because of this bracket sign, so we multiply what? The exponents. Are we together?
Yes.
Are we together?
Yes.
Similar, if you're applying the multiplication law for this case, how many bases do you have? 1. Which is what?
4.
4. How many exponents do you have?
6.
6. 3. So 6 plus 6 plus 6 is equal to what?
18.
18. So this is 4 power t power 18. By using the first law of multiplication. By using by using this law, we had what? 4 power t power 6 power t power 3. Right? This is equal to what? 4 power 6 times 3. Remember that this is 3 power 4 times 2 is equal to what? 3 power t power 8. Right?
Yes.
And here we have base of 4. 6 times 3? 18. So you have 4 power t power 18. So whatever the law you are going to apply, you will get the same answer. Are we together?
Yes.
But you find that this one simplifies life, right? Because sometimes writing the expanded form, you can find that, for example, suppose that here you have power 6 or power 12. So you have to write this, so you see you have a long, and sometimes you can confuse yourself. That's why we are introducing laws to simplify what? Life. Are we together?
Yes.
Are we together?
Yes.
So now you have to keep in your mind, there is another law that, for example, that we say A power m times what n, this is equal to A power m times what n. But also you can have maybe 3, maybe A power m, power n, maybe power t power r. Do you remember? For instance, for this case, you just take A power m times what n times what r. So nothing difficult. So whether you find a question in 2 exponents like this, or maybe in 3 exponents like this, don't worry. Just apply the same laws and keep the questions, and then you are waiting for your marks. Are we together?
Yes.
So we are training you these laws, and you will need them. I tell you, for example, in the first chapter, which is called logarithms, we are going to teach you about laws of logarithms, and you will find these laws also are very important, because these are still laws of what? Of multiplication. Please write down on what you have been writing, please. These are very important information for you. So, ladies and gentlemen, let me present example 12 for you. Write the following expression. Write the following expression. Write the following expressions using a single exponent. Using a single exponent. Using a single exponent. A is 3 power 6, then exponent what? 3. B, we have 3 over 7 power 6 power 2. And C, we have 0.7 power 7 power 3. That's the question we have. And all of those questions are come from your secondary based mathematics tool too. Okay?
Yes.
Solution. You are allowed to pause the video if you are online, and then you try these questions on your own. So remember that this is 2. This is 2. Many students say that I didn't see it. And this is 6. Okay, so solution. So The first step, whenever you encounter any place of exponents, you have to think what law should you recall. So you have to recall what is recall the second law. So recall the second law of multiplication. Multiplication of what? Of exponent. Okay, of exponent. Right? So how does it state? You say that you have exponent with base of a, exponent of m, then open and close bracket, power n, or raise n. This is equal to what? A power n times what? Times n. That's the law. So we check for Roman A. 3 power 6 power 3. So for Roman A, you'll be given 3 power 6 times power 3. So if you compare, you find A is equal to what? 3, M is equal to what? 6, N is equal to what? 3. Right?
Yes.
So you have left hand side, you have to find right hand side. You have left hand side, you have to find right hand side. So we have been given what? 3 power 6 raised of 3. This is equal to what? 3 power 6 times what? 3. Right?
Yes.
Huh?
Yes.
Because on the right hand side is m times n. So we multiply what? Exponent. So 6 times 3, what do we get?
18.
Huh?
18.
18. So 6 times 3 is equal to what?
18.
So therefore, to write 3 power 6 power 3 in a single exponent, this is equal to 3 power 18. That's the response. These are still simple questions for the Form 2 students. Roman B. Roman B will be given what? 3 over 7 power 6. And this one square. This is equal to what? So if you compare, so if we recall the law, a power m, then power n, this is equal to a power m times m. Right?
Yes.
Right?
Yes.
So if you compare, we compare, let's say, expression 1 and expression 2. So compare expression 1 and 2, when we find what? A is equal to what? 3 over 7, right?
Yes.
M is equal to what? 6. N is equal to what? 2. Right?
Yes.
So to find 3 over 7 power what? Power 6, then power 2, this is equal to what? 3 over 7 power 6 times 2. 6 times 2?
12.
12. So this is equal to 3 over 7 power what?
12.
So therefore, 3 over 7 in a single exponent, power 6 power 2 is equal to 3 over 7 power what? Power 12. So see, mathematics is the simplest subject, especially this mathematics that we are dealing in section 4. So Roman C have been given 0.3 or 0.7. This is the base, power 7, power 3. right? Power 3. So what the law? So we have to recall the law. The law is A power M power N. This is equal to A power M times N. Right?
Yes.
So if you compare, A is equal to what?
0, 7,
M is equal to what?
7,
N is equal to what?
3.
3. So, in this case, we say that you have 0.7 power 7 power 3. This is equal to what? Is equal to 0.7 power 7 times 33. The answer is equal to 0.7 power
21.
So, the response 0.7 power 7 power 3. This is equal to 0.7 power 3. The response. Mathematics is beautiful. Please write down what I'm teaching you. So let me teach you the set multiplication law. That was second. Thirdly, multiplication law of exponent. Set multiplication law of exponent.
Multiplication law of exponent.
So with this, we are still dealing with multiplication. Right now, we want to deal with different base. Different base, but the same exponent. Right? So if 2 or more than 2 exponents are more than 2 exponents with of the same of different base bases with same exponents. The same exponents are multiplied together. Then let me read on what I've written. If 2 or more than 2 exponents of different bases with the same exponents are multiplied together.
If 2 or more.
No, there's only for you to read. Just I was reading for you to see what I've written. So then we can simplify them by using this law. So we say the multiplication law of exponents will be applicable. So let me summarize the information or the sentence that I've written before. Suppose you have 2 exponents, so listen carefully. With base A, and then its exponent is n. Then we multiply with another exponent with base B, but exponent n. Right? See that? So this one, in mathematics, we can write we have A times B power the same exponent of n. So these are the 2 exponents, right? Or 2 power form of the numbers, of letters. But they have different base. A is not equal to B, remember that. And then n is equal to n, but the same what? Exponents. Remember that in the first law, we had 2 exponents, or more than 2 exponents of the same base, but different what? Exponents. Right?
Yes.
Right now, we have 2 or more than 2 exponents of the different base, but we showed the same what? Exponents. So it means that this is the law that you have said. But given that A is not equal to what? To B. It means that these are the different what? Exponents. Or we can write, if we be given the problems as A times B power n, we can write in what? In expanded form. So expanded form.
Expanded
So
form.
this is the single exponent. If you write in this way, it is a single exponent. Then we can write in two what? Exponent. And this is A power n times what? B power what? Power n. These are the single two exponents. This is the single exponent. These are the two exponents. This is the single exponent. Are we together?
Yes.
Are we together?
Yes.
So, but remember that the condition here, A is not equal to what? To B. So this said law, it might be in this form, from this form to this form, or from this form to this form. Are we together?
Yes.
Are we together?
Yes.
Are we together?
Yes.
Just the simple demonstrations of this example, you have 3 times 4 power what? Power 3. See? So this is equal to what? You can find this, the response of this multiplication by what? 3 times 4 is equal to what? 12, right? Then you find 12 power what? Power 3, which is equal to what? 12 times 12 times 12, right?
Yes.
Alternatively, we can find that 3 times 4 power 3, this is equal, open bracket, 3 times 4, close bracket power 3, this is equal to what? 3 power 3 times 4 power 3. So 3 power 3, we know that is equal to what? 3 times 3 times 3 times 3, right? Which is equal to what? 27. And then 4 power 3 is equal to 4 times 4 times 4, which is equal to what? 64. So you have 27 times 30, 64, which is equal to 12 times 12 times 12. All right? That is what we are saying. Also, you can find that maybe you have x power 3 multiplied by what? Z power 3. So also this we can express as x times what? Z power what? Power 3. Because the base is not the same. The base here is x, the base here is what? Z, but the exponent is the same. Right together?
Yes.
So nothing is difficult. So let me go to example what? 13, yeah?
Yes.
Huh?
Yes.
Okay, so let me present to you example 13, which will clarify or give you more details about the third law of exponent. So example 13. Expand the following. Expand the following expressions. Following expressions. So that each base is raised to a single exponent. Single exponent. A 7 by 2 times C power 3 power 4. Then B is 4 times B times C cubic power 3. Then C (0.7) power 4 times 0.3 power 2 and all of this power 4. Afterward, I will give you the homework. It will be the end of this session. Expand the following expressions so that each base is raised into a single exponent. That's the question. Expand the following expressions so that each base is raised into a single exponent. Each base. So understand the keyword is each base is raised into a single exponent. So first of all, we'll be given those exponents in a single exponent, but with a different base. So solution. So the first step, if we check our questions, if we check our questions, right?
Yes.
First of all, we find out how we need a second law which guiding exponents of the different base. Why? Because the base of this exponent is 7, while the base of the next exponent is c. So is 7 equal to c? No. The base of this exponent is 4. And the base of the next exponent is b, the next is c. Is 4 equal to b equal to c? No. The base of this exponent is 0.7, and the other one is 0.3. Is 0.7 equal to 0.3? No. So these are the exponents of the different base. As I gave you a promise when I was teaching the first law, I told you I will teach you how you can deal with exponents of different base, and this is what I'm teaching right now. So you have to recall the said law of exponent. So the said law of exponent, how does it state? It states that if you have a times b, right, power n or power m is equal to a power n times b power n. This is in case we have what? The exponent. But I guess if you have a times b times c, all of this one raised by what? By n. This is equal to what? A power m, or a power n, okay, times what? B power n times what? C power n. These are the exponent raised. These are the single exponent. Each base raised to a single exponent. Right?
Yes.
So if we go for Roman R, we have what? We have 7 power 2 times what? C power 3 power 4. Is it?
Yes.
Huh?
Yes.
So listen carefully. So here we have to be careful because we are going also to refer the second law of multiplication. So if we refer this law, so how many exponents do you have there? 2. A times what? First of all, we have a power a certain exponent, and then we have the x and exponents. Listen carefully. So the second step, in order to solve that question, second step, you have also to recall what? You have to recall when you have a power m times n, we say this is equal to a power m times n. Right?
Yes.
So let us apply the first law. Listen carefully. So 7 power 2, this is equal to what? 7 power 2, 30, exponent 4, right? Multiplied by what? The next exponent is what? 3 power 3 power what?
4.
Right?
Yes.
Why? Because this is a certain exponent, but raised to 40 or 4. Are we together?
Yes.
So if we start dealing with 7 power 2, then exponent 4, this is equal to what? If you're applying this law, is equal to 7 power 2 times what? 4, right?
Yes.
So this one is equal to what? 7. 2 times 4?
8.
8.
So 7 power 8. Right?
Yes.
If we take this part, which is 3 power 3, but outside you have exponent of 4, this is equal to what? C power 3 times 4. 3 times 4 is equal to what? 12. So this is C power 2. Are you together? So you see now, the questions start getting challenging.
Yes.
So therefore, for man A, 7 power 2 times what? C power 3, and all of this is stuff, power 4. This is equal to what? 7 power 8 times what? C power 12. Are we together?
Yes.
So this is the final response. So you see that this exponent, this base has a single exponent and this base has a single exponent. Are we together?
Yes.
So here we applied how many laws? 2 laws. Third law and second law.
No.
Second law. Are we together?
Yes.
Okay. So if you didn't understand, we can go for Roman B. Roman B, so let us do together. We have what? 4 times B square times what? C cubic square, right?
Yes.
How many exponents do you have? 3.
Yes.
1, because 4 power 1. If you find the number itself, means it is power 1. Any number power 1 is that number. 9 power 1 is 9. 10 power 1 is 10, right?
Yes.
Or we say that 20 exponent to 1 it is 20. 21 exponent to 1 is 21, right? So this is 4 power 4 exponent to 1. So how many exponents do you have? 3. 1, 2, 3. But all of them have what external exponents of what? Of 2.
2.
How many laws are we going to apply? 2 laws. Third law and what?
Yes.
And second law. Right?
Yes.
Eh?
Yes.
How are we going to apply the third law? So third law. How does it state the third law? A times what? B times what? C. Right?
Yes.
Power what? For instance, power n is equal to what? A power n, right?
Yes.
Times what? B power n times what? C power n. Are we together?
Yes.
But these also are what? Exponents are not bases. So because the exponent, we say that with this law is equal to what? 4 power 1 times what? 2, right? Eh?
Yes.
Multiplied by what? B exponent 2 power what? 2 multiplied by what? C exponent 3 power what? 2. So there we need which law? To simplify it, which law do we need?
Second law.
Second law. Why do we need second law? Because we have the same base, but we have to multiply the exponent, right?
Yes.
So the second step, we have to recall what? Second law. How does it state? Second law. A power n power n is equal to what? A power n times what? N. How many exponents do you have there? 3.
3.
We have 4 power 1 exponent what?
1, 2.
2. This is equal to 4 power 1 times what? 2. The answer is equal to 4 power 2.
2.
You are not allowed to find a value. You are being asked to write in the single, each base raised with a single exponent. Right?
Yes.
Read the question. Expand the following expressions so that each base is raised to a single exponent. So you go for the next part is B what? B power 2 power 2, right? This is equal to what? B power 2 times 2 is equal to B power what? 4. The next part is what? C power 3 power what? Power 2, right?
Yes.
This is equal to what? 3 power 3 power 2. The answer is equal to B power what?
6.
Power 6.
C.
Huh?
C power 6.
Not B.
It is C, thank you. Thank you very much. It is C power 6, right?
Yes.
So therefore the answer is equal to what? It was 4 times what? B square, right? Times what? C power 3, the question. Then power to power 2 is equal to what? 4 power 2 times what? B power 4 times what?
C
power 6. That's the response. Now, mathematics is getting into mathematics. Before it was a breakfast mathematics. So now we are getting into lunch. Right?
Yes.
So then we go for Roman C. Okay, for Roman C. Roman C. Can you go straight forward? We have what? We are going to have what? 0.7 power 4 times what? Times 4. Then multiply by what? 0.3 power 2 times 4. You understand?
Yes.
Huh?
Yes.
This 4 is multiplied by this 4. And this 4 is multiplied by these 2. Right? Straightforward. So 4 times 4?
16.
16. So 0.7 power 16 times what? 0.3 times what?
8.
And the response. Have you finished to copy here?
Yes.
Huh?
Yes.
Have you finished to copy this part?
Yes.
Huh?
No.
No. What are you still writing? So copy please, so that I may give you the homework. And you have to make sure that you repeat. Okay, so now it is time for the homework. I'm about to end session 4, which titles laws of exponents or law of products of exponents. So we have homework, and this is homework 4. Simply just recall it in H4. But in numbering, this is example 14. And the question state that is come from your book. Rewrite the following expression. Following expressions. By grouping together those with equal exponents to appear and a single exponent. And a single exponent. A is D 4 T power 4. B is A power 5 times B power 4. C, we give you 3C D square times 5C power 5 D power 4. So we write the following expressions by grouping together those with equal exponents to appear and a single exponent. Okay, today it is enough. So this is the end of session 4. Thank you very much for joining me and having me in this particular session. I believe that you've been enjoying the beauty of basic mathematics. In case you have any question, please ask in the comment sections below. Don't worry. And remember also to subscribe onto our YouTube channel in order for you to get notifications once we upload a new video. Keep on inviting, keep on enjoying, and join me in the next session, which is session 5, when I'll teach about other laws of exponents so that you may enjoy and apply exponents in your daily life. So may God bless you and keep you until we meet in the next session. You understood?